However, when we talk about gRPC, then about scalable, specifically the concept of revolutionized distributed system communications. Okay, so my name is Adnan Umer. I'm specifically an implementation engineer to PyCon nowadays. So that I'm doctor and I spend and I'm one second father of Vodafone. Alongside that, I passionate about self contributions. Some significant contributions which I know, and I was a teaching there. As well as that, I'll tell them my presentation on. So moving on to what we're going to talk about, the first thing we're going to talk about is what is more procedural path and how basically the interface protocols specifically in general evolve. We're not just looking at a word which just exists, but some protocols that are with that. We'll talk about what is gRPC, how we use and evaluate with gRPC, what are the real world examples of using a gRPC, and how we are using that at its front. And lastly, we'll talk about some challenges and considerations to date why we do gRPC, or which are we need gRPC. Okay, so first thing, what is RPC? So basically, it's just it's a protocol that allows us execute a procedure of another program that is executing on a different machine. And from the mind perspective, basically it's just an extension of client server protocol. And from the mind side, it's just like we're executing a function of but that's actually being executed on a server side, and you get the result on the web side. Okay, so what that allows us, we can have both binaries are using different entities. For example, you can see we have our client returning role that is executing a function that's flowing within a basically Python application that's running on the server side. So the communication happens over the network, and RFC protocols allow us to basically distinguish do seamless communication between them. Okay. So talking more about RPCs, so basically that was first not as a revolutionary to 1981, but the theoretical proposals of the communication and basically execution of word on network machines gets back to 1970, where the initial upper and then was correct. The first implementation that aware of first proper implementation of RPC by some microsystems in 1980. Fun fact about some microsystem, it's a Stanford University network specifically, and they have basically put a lot of effort into the development of Unix and also as well as network communication. And we can see some microsystems in a lot of ways when we talk about networks. Okay, so first thing when we talk about networks, interface protocols, the first one was the once the open network computing remote procedure call, that's also known as Sun RPC, that's written by Sun Microsystems. That was the first implementation, the first open implementation in 1988. It uses the TCP or UDP basically socket for the communication. And there was a way to serialize an object and transmit to that over the network and that sort of stuff. But there was a limitations that was not language platform independent. There was a platform independent, so there was another copy networks popular protocol known as Cobra. That was the first object-oriented basically model, and although the language that is implemented that does not require object-oriented, does not has to be object-oriented, but the protocol was itself object-oriented. That was quite a major basically protocol that's used for a long time. That dates back to 1991. It was achieved TCP over IP, but in later versions like in 2007, there was a vision for that allows us to communicate and do the communication with the HTTP. We know the next one we have distributed computing environment, RPC. That was that's quite similar to Cobra, but that was an open standard almost 32 this joint effort of officer at that time. That's basically program, and it's also uses TCP or IP for the communication. But sorry, COBRA, COBRA. It's COBRA. Common Object Request Protocol.
With this one, I'll work that.
Okay, now. Okay, sorry. Okay.
Oh,
yeah. So the distributed Kubernetes environment obviously was similar to PyCon, and if you want to use some authenticated file, you can use Samba like for communication, but that was basically primarily used over GCP or we want to next Microsoft in the field, and Microsoft has an architecture called inter-process communication protocol, and they exclusively use basically DC, and that came to basically existing that basically gave rise to the DCOM. It's just communication protocol. Microsoft has a feature. So it was a major competitor to Forba, and but it's quite similar to DC. Yeah, and then in 1988 there was let's just use XML serialization over HTTP, and then it gave rise to XML or RPC protocol. This was just like you word-wise object serialization XML transmitted over the network. Specifically HTTP protocol, and just give my users in all applications of the everywhere. And next, basically, the Java W specification was a subset of Java storage specifications. The subset of Java W specifications was HTTP. That was our enterprise level communications, and it initially was designed to handle the data, the Java serializable objects, and what later is for XML and so on. That also uses TCP protocol, but they have another protocol on top of that. The import method innovation, but later on they replace that with HTTP. Perfect. Sun Micro Systems eventually adopted this protocol in 1999. And last peculiarity is REST. It's not a protocol. We sometimes refer to it as a protocol, but it's not a protocol. It's just an operating state. Just like Israel, we want to follow it, otherwise we can just throw in that. It's just communication on HTTP. Just use that, and we generally use JSON and as a method of object serialization. Like XML there was the advanced measure that's known as SOAP, the addition was that there was an web service, there was another discovery language used to describe the that defines the services that can be shared, that can be invoked by someone else, and that was just an extension to gRPC. Then GraphQL was introduced in 2012, and this public release was 2015. The GraphQL basically when Facebook was listening to that the problem was if the APIs evolve, the problem is the client needs to rather request more things and things like that. But if you want to allow the client to specify to exactly say what I need from the client, and that was exactly the motive behind the GraphQL. That was a standard basically C1 definition, and which was introduced in 2018. But GraphQL basically came into the 50s, publicly available. And then in 2015, gRPC also was introduced. gRPC is the final protocol that we're going to talk about. So first thing, what is gRPC? So gRPC specifically is an high performance and open source feature-rich framework that is developed by Google, and but now this is not owned by Google. It's basically a part of now cloud connected foundation. It's on and we commonly refer to gRPC and it's developed by Google to say okay, it's something like Google. G stands for Google, but it's not. Google can be anything depending upon the version that is using. It can be Word or where anything is available. So basically, there's a complete documentation. Even gRPC has publicly published where for all the versions what G standard for is specified. Okay. Basically, Google it has Google is exactly using a framework that's known as this protocol study that's used extensively, but that's not that's closed source. We can say that is a closed source version of gRPC. gRPC is much mature. There is others new, but the protocol itself is quite visual because Google is investing in the cloud resources on the different methods from environment. Okay, so now because of this, why we need gRPC? The first thing is yes, like this is language independent. You can use any languages, of course, multiple languages, and the thing is because it's based on HTTP 2.4, it supports bidirectional streaming. Bidirectional streaming is something that work with most of protocols don't have, and next we will do multiplexing. Using multiplexing, basically you can share same direction and that it is theoretics quite basically. There are tricks of things, and another reason gRPC is popular because microservices are popular for some reasons, and gRPC is quite a good tool if you want to use the protocol. If you want to do a relation between multiple microservices, quite fast with okay, so how basically gRPC exactly works. So both client and server share some shares this a definition of what is exposed by the service, and that based on that, then we stubs are generated. The stub is basically known to both client and server, and the thing is some developers like services is some language C++ and one we use that is doing that in some say Python. So because gRPC can be ported supports multiple languages, we can stop some multiple generated multiple languages, and we can just communicate it with we can just invoke that. It's just like looking like you are invoking like global functions.
My questions like how we react and lead on this topic.
Yes, basically there is another language. We talk about that in a moment, and that is protocol, in which to define what this service has to offer, and that starts using that stuff and the protocol of compiler and the gRPC extensions for that language, which is next stuff. That's this automatically by gRPC in our world and in that stuff. Okay, so to what that how basically stuff are generated, we have the ambient object definitions. There's we generally use protocol, but gRPC is not limited to protocol. Kinds of like actions that we have a profile that can react this. We specify a message, say the request itself, it fixes type objects, and then we specify another whatever service. And you can say we have a welcome service in which obviously is defined that says hello, which accepts hello request and returns an hello response. So it's just who wanted to like word. It's quite easy to understand language, and that's how we basically specify what when a service has to offer to the client. Talking about Python, you can generate stuff with Python to gRPC tools, use a pay-by package, and just ensure that when you look at gRPC tools versions are the same, otherwise there will be problems. Just as a quick one, do a lot of examples on that. officially, we will just talk about some basic examples. So first, like let's say we have hello world example, the basic one. In which we have a service test and a speaker, which is the method say hello, which request hello, and you will get a response. This is internet. So the request just has a one object that's in the message there. Sorry, field that's in the name and reply also has something on message. So first we generate stuff for client and server tool. So let's say we have this stuff. This is for the server, and this is generated. So we are inheriting from that, and we'll just assume that because Python JS is not directly supported by Python. It's just C binaries, and the report is not badly developed. So I'm just telling you, but languages like say .NET, Go, the generative stuff is quite real. Like gRPC natively support that, it's natively supported, but all these values are generated by binaries, semantics, and the problem is that there are some workarounds and for generated code is not that. Okay, so let's see whatever the code is just like. We have to define a function exactly the name of the function that is defined by basically profile and that accepts the request on a context. The request basically is just an object of whatever we have specified. Like in this case, we have specified request having request. This will be available as a request here. So I think this response will be basically when we just send whatever the message is, whatever the thing is, we just hello name. And this is just a simple option to run on gRPC server. There's most probably you are going to work there like this, but this is just an text development. From the client perspective, you just open a single function, you use that stuff, and then you just take it into the function, and that's a great response. From the next perspective, it is quite simple. Okay, the question is why should we use protocol buffers? As I specified previously, gRPC is not limited to protocol buffers, but that's by default. First one, more common thing is it's common. The official language is quite common variable. There is no special syntax we need one there. Yes, there is a syntax, but that's quite common variable. And the protocol buffers is what basically language variable like when you talk to any language is what like that. Okay. So protocol buffer is a minus serialization method. What that means is basically the size is quite small. It's faster in transport. The definition, the syntax is not transmitted like let's say JSON. Almost the schema holds around 20% of the size, and also because there's not. If we wanted to communicate, say, binary images over the network, that's not possible without serialization. Just one network of a communicator just transferring bytes as it is. Out of the box, protocol buffer stores a compression, and it's a strongly type. And you can also use some other alternatives, just like local credit over the number of minor compounds, which just works on other objects. So now the question is why gRPC in other words, why you want to use gRPC over that when you are talking about communicate migrating with like in the Microsoft word why you are going to use gRPC. The first thing is that space basically mostly JSON. We have on the other hand on gRPC we have protocol buffers. We have much more support for we can operate any kind of data both most probably computer JSON is limited to valuable objects. Few things on the list of list object string and numbers. That's it. But in gRPC, it's a sign you can use password. All kind of data. The second thing is let's just try to use HTTP 1.1, but gRPC use HTTP 2.0. We want to do a price comparison. Say we want to do about 200 images over HTTP 1.1. And it takes around 40 to 50 seconds. After you use HTTP 2.0, that same 200 images can go and then watch it. That's the way. So that's quite fast. The HTTP pointer is quite fast. If you want to do some streaming, in REST that's not stored. Specifically, just does not store streaming resources. You have to do some other techniques, and regarding client-side improvement, the server-side implementation does not usually support streaming. But in gRPC, because of HTTP 2.0, the bidirectional streaming is supported. This timestamps and string data server and something also string data group. Right. So now the question is why not? We could just like WebSockets, but it's not. We can just look into that. And if we give you the WebSocket, but we can't use. We can't use to replace. So we can't replace WebSockets, which is. On the data side, because it's not a protocol, everyone has different ways to put things, and there is no specific code solution. Yes, they asked that what is looks like Swagger, but there are most of the time we prefer to be just use raw lines to provide some generic stuff, but on the gRPC side, we have a quite good code solution for it. From a programmer's perspective, it's just slow because it's human and gRPC is use this password because the usage of HTTP 2.0 and also for okay, now the study is where you should use gRPC. The first thing is yes, if you are using microservices, I think you will have microservices to should use gRPC. gRPC is provided for the microservice architecture. Basically, the response time is critical. Like we can minimize and if this you have a few services communicating with each other or HTTP, you are definitely going to history that I have 200 milliseconds response time from the end perspective. But if you are using gRPC, we can make a response from critical services in less than 50 milliseconds, like actually sometimes in less than milliseconds. So that's very fast. Okay. Cross language communication, if you want to do some cross language communication, like you have multiple application, multiple parts of project written in different languages, so you can just use gRPC to quality communication. If you want to you have some high performance APIs, use gRPC. Yes, you can validate APIs to using gRPC. And if you want to boost streaming data, you almost between gRPC. Otherwise, you have to either use HTTP 2.0 or come up with some on-best solutions. Basically, in distributed systems, basically in some tools like product tools, if you write that gRPC plays quite a hand with it. You can also use the same Internet of Things if you want to go it, because there are consideration to that. So we will talk about that. So a few very examples of gRPC. gRPC is used extensively by Kubernetes. If you use that, how they develop communication inside Kubernetes happens on gRPC. And all the usabilities, we can just use gRPC teams up where Google does not use gRPC, it's just another way it's gRPC is like this way. But in real world, in the microservices version, gRPC is quite active, otherwise that's not good. Okay, now so talking about start from this is a data science company. We ML and AI institutions. We have a big lot of people working in data science and few people to achieve was just working on in data science. And we when we are going to develop when we have feedback models, whatever machine learning models describe at scale, we it was the gRPC data. Public information I can't share the details, but that's added secretary. We do have a product depleted right AI that's just posted. We have it's just a solution to have managed hosted analytics models over HTTP APIs. In generally, all models are deployed as a standalone application, and we have an operator that actually discovers all the models that are available and we use this higher English. Okay, so last we will talk about another checklist and presentation that we are using gRPC. The first thing is resource constraint. Like gRPC requires a lot of resources, and if you are to rely this thing on some small device that which has few resources, gRPC is not going to work well. Second, if you want to use that for WPS, and then please make sure that because HTTP 2.0 implementation is not supported across all the node, and even that's not even same could work like, and you have to take that into consideration. And we should really avoid using writing WPS. Because it's if there is some evolution, I think it will not be quite hard to develop. Like it's very hard to develop the tooling and even developers for such things that you can't like that good. And because it's new to the community, this sport is outside of it. Also, gRPC does not support real virtualization. So if you want to do that, you have to look into either when it comes come up with your own solution, or you have to just use some other alternatives. We say gRPC is quite fast. That's very performant. But if you have high load and that load is not view, gRPC comes with some limitations, and there's not quite slow. So the fixed performance as the first load is not that high, and connection is not long. So I like it. I don't want to use it. Another thing, because gRPC uses behind the scenes certificate ambitions, and if you open too many streams, that become a problem. And eventually, the gRPC will suffer performance issues, and that's why we can't use as a use opinions. So that's the thing. You can have other questions. Yeah.
And this guys to have for that. If we to set up one of the sort of time restrictions.
So it's going to be a very basic question because this is the first time I come explain to this. So let's say I have a REST API server and I make it secure by I do some authentication, and then everyone has to be authorized to be able to call my APIs. So how can we make does gRPC also have a server? So how can we make the communication secure so that nobody else? Is it similar to how we do it in REST, or what makes it same?
Yeah, basically, talking about REST that's based on HTTP, all the securities that we have for the HTTP are also applies to gRPC. We have the same securities. But if we talk about, we do have our customers of gRPC as a sponsor, it's a function of communication. And basically, it does support TLS, the file encryption, but the security from a service perspective, the serial authorization gRPC does not have that. We have just very basic combination, and so you have to come up with these own stitches. Which one?
Yesterday. In the available, I could meet these people.
Thank you. Sorry, I will not take any questions that you had. So, we'll swear for paragraph.